Today's lab is about metal replacement reactions. Essentially what we're looking at here is that certain metals are more active than others. And there's a accompanying sheet with this that has the metals from the very most reactive, called lithium, all the way down through the neutral one, which is hydrogen, down to the least reactive one, which is gold. And so you should have that table with you, because unfortunately we're not going to be able to be in the lab itself to carry out this experiment. But the whole point is that if you have a salt, with X here being a metal and Y being the anion, and place it in contact with another metal, the more active metal is going to replace that one, assuming A is a more active than X. So what that means is that any metal that is higher on that list will replace one that is lower on that list in this sort of a reaction. So fortunately we don't have to work with lead compounds, and the silver nitrate, yes, that makes your skin very, very black. But essentially what this experiment consists of is taking metal strips, of one of copper, one of zinc, and one of lead, and the purpose of the sandpaper is to roughen up the surfaces so that they can possibly react when they get into the solution. And the idea is to take the different test tubes, and in them you put different salt solutions. Okay? And the first one that you're going to be putting in will be one of silver nitrate. Okay? So you have 3 tubes. You have each one of them filled with a certain amount of silver nitrate solution. In them you will put one of the 3 metals in each one of those. You'll have a zinc one, a lead one, and a copper one in each one of them. And what you do is you carefully look at them after a certain period of time and see if there's a deposit on the metal strip. And if there is a deposit, that means that you have a reaction taking place there, right? So anyway, and you repeat that with the 10 milliliters for each of the different metals. And then what we're going to do is, after you've finished it with the first time with the silver nitrate solution, then what you're going to do is you're going to do the same experiment where you have 10 milliliters of copper nitrate. And then finally, you're going to have 3 with lead nitrate. Okay? And so there's a table at the end that has and here, right here, you have the copper. You're placing that in the silver nitrate solution. And then you'll write you should write the balanced reaction over here for what happens. Zinc in the silver nitrate solution, and see what happens there. Lead in the silver nitrate solution, what happens there. Then you have copper in the copper nitrate solution, zinc in the copper nitrate, lead in the copper nitrate. And then what you have in the final one is you have you have copper in the lead nitrate, zinc in the lead nitrate, and lead in the lead nitrate. Just a little hint. If you've got lead here and you've got lead here, no reaction is going to take place. Likewise, on the one prior to that, when you have copper here and copper here, no reaction is going to take place. So in this particular one and the other one, you just write no reaction. For the other ones, what you'll do is you'll write what actually took place. And you can base that upon where they are in terms of their relative activity on that sheet that accompanies this. So once you have all of that finished, you fill out this table at the back. So we have silver, zinc with silver nitrate, copper metal with silver nitrate, lead with silver nitrate. then zinc with copper nitrate, copper with copper nitrate, lead metal with copper nitrate. So you already know that in this box right here, you'll say no reaction, right? And you'll also have a no reaction in this one. Now what you have to do is you have to figure out what happens here, what happens here, 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 and here. And base your prediction upon the relative activity. Is this metal higher or lower than this metal? If this metal is higher, it's going to react. If this metal is lower or equal, it's not going to react. Okay, so you should be able to fill this out based upon that prediction. It's not quite as good as if we actually had the time to go in the lab and do it, but essentially what you should be able to do from this is be able to see how these things work. Now, there is also one other thing on this. You've got this invitation to further inquiry, okay? So what I would like you to do on the following sheet of paper is to go through this list right here and ranking these from highest to lowest in terms of activity, and then try to figure out a similar way where this might be accomplished to determine that experimentally. So rank them and then write down what experiment you would do, similar to what we did here, for a reaction to demonstrate that level of activity. Okay? And then where nickel would occur in that list as well. That's all you have for the lab tonight, and I hope you enjoy it and understand and appreciate this. If you want to, you could probably go online and find some place where these reactions take place or don't take place if you want to follow up with that part of it as well. But anyway, that's the end of this lab. I look forward to seeing your reports.